So we are going to start with Mathematics Paper 1 for 2019 GCE. So the first question is here. I just hope we are able to see clearly. So the question is saying simplify 4 minus 2 multiplied by b minus a and then minus 1. So to be able to simplify this one, it is going to be a direct thing. The first thing we are going to use board mass. So board mass meaning brackets of division, multiplication, addition, and then subtraction. So the first thing that we are going to do is brackets of. And how do we do that? So we are going to get first this 4. We are going to write it the way it is. And then now we are going to get this negative 2 we are able to see here. And then we are going to multiply with what is inside. So this is going to be 4. The negative 2 times the one which is inside the b, that is going to be negative 2b. And then negative 2 multiplied by this negative a, negative and negative, they become positive. So that is going to be positive 2a. And then we're going to get a negative 1 which is at the end there. And then here we're going to put like terms together. So I'm going to get 4 and then I'm going to get this one, but it is negative, so it will be a negative 1. And then I'll get the negative 2b the same way it is, and then the positive 2a the same way it is. So 4 minus 1, that is a 3. And then we have got minus 2b plus 2a. So we can't do anything more than that because these are all unlike terms. Therefore, that's the final answer. 3 minus 2b plus 2a. You can also write it as 2a minus 2b plus 3. However you write it, it doesn't matter which one you start with. And so please, when you've got a question, just open the mic, you speak. So let's go to question 2. Question 2 is saying evaluate the fourth root of 81 raised to the power 3. Fourth root of 81 raised to the power 3. So how can we work it out? So what we want first to look for is the fourth root of 81. What does fourth root mean? What number can you multiply 4 times for you to be able to get 81? So the first thing that you do, because you don't use a calculator, we're going to get this 81. You have got the small numbers starting with 2, 3, 4, 5, 6. So what you are going to be doing is start first with a 2. Ask yourself, can 2 go into 81 without leaving a remainder? We know that 2 cannot go into 81 without leaving a remainder, so no. Okay, since 2 cannot go into 81, we are going to go to 3. So we're going to write like this. So we're going to ask ourselves, how many times can 3 go into 81? The first thing, we know that 3 can go into 6, that is 2 times. So it can go into 8 2 times, remainder 2. And then how many times can 3 go into 21? Okay, so if we check what number can we multiply with 3 to get 21, how many times can 3 go into 21? We know that 9 plus 9, this one is 18 plus 9. Well, that is not it. So 7 plus 7 is 14. 14 plus 7, that is going to be 21. So 3 can go into 21 7 times. So 3 into 81 is going to go there 27 times. Again, we'll go again. Can 3 go into 27? No. I mean, 2 can 2 go into 27? It can't go there. So let's try 3. How many times can 3 go into 27? We know that 3 can go into 27 9 times. And then again, can 2 go into 9? No, it can't go there. What of 3? Can 3 go into 9? Yes. So 3 into 9, how many times can it go there? 3 times. So these numbers were able to see 1, 2, 3, 4. It means when you multiply 3 4 times, you are going to get 81. Therefore, I can also write this as 81 is the same as 3 to the power 4. meaning that 81 is the same as 3 times 3 times 3 times 3. So I can write this as 4, fourth root of, where there is 81, I'm going to write 3 to the power 4. And then this is raised to the power 3. So what we are going to see is this fourth root and this power 4, they are going to cancel out. So what we are going to remain is 3 to the power 3. And we know that 3 to the power 3 is a 27. Meaning 3 to the power 3 is just 3 times 3 times 3. 3 times 3 is a 9 times 3, that is a 27. So this is going to be the answer, 27. Okay, let's consider question 3. Question 3, factorize completely 32 x to the power 2 minus 50. So when we want to factorize this one completely, the first thing that we are going to do is we're going to look for a number that can go into 32 and 50 without leaving any remainder. And of course we know a 2 can go into both without leaving a remainder. So we're going to say 2. Now how many times can 2 go into 32? We know that is 16 times, and then we're going to have x squared there. How many times can 2 go into 50? We know that is 25 times. And this is going to remain as 2. We have got, now these numbers 16 and 25, they are called perfect squares. 16 is the same as 4 to the power 2, and then we have got also x to the power 2, and then 25 is the same as 5 to the power 2. So when we have got 4 to the power 2 and x to the power 2, I can write this as 4x, and then I'll put them in brackets because both of them have got power 2. I'll just put the 2 outside. So this is the same as 2, open brackets, we have got 4x power 2, and then minus 5 power 2. Whenever you've got a number like a squared minus b squared, you can write this as a minus b and then a plus b. This is called the difference of two squares. So in this case, what we are taking as a is 4x, and then what we are taking as b is 5. So we can also write this as 2, the 2 is outside, and then the a, which is 4x, we are going to write it, and then we write minus b. Now b in this case is 5, and then we also write again the same 4x, but we are going to use now a plus b. Now a b here is 5. So we factorized completely for this one also. That is how you go about it. We're going to question 4. Question 4 is saying find the gradient of a line which passes through negative 5, 3 and negative 4, 1. We need to know the equation of the gradient of a straight line. Gradient, the symbol is m, is given by y2 minus y1 over x2 minus x1. So we are going to take what is here as 1s and what is here as 2s, or if you want you can change them. So whenever you are writing a coordinate, you always write as x comma y, meaning that the first coordinate that is given is always x. So this is going to be x1, this is going to be y1, and then this is going to be x2, this is going to be y2. So using this, we're going to now put in this formula y2 minus y. So what is y2? You can see y2 is 1 minus what is y1? We can see y1 is a 3 divided by x2. Now what is x2 in this? We can see that x2 is here, which is negative 4 minus. The minus is coming from the formula here, minus x1. What is x1? We can see that x1 is negative 5. So negative 5, we should put it in brackets like that. If you change, it will change the answer. So on top we've got 1 minus 3. Whenever you're subtracting a big number from a small number, the answer is going to be negative. So 1 minus 3 is negative 2. And then down we have got negative 4 minus negative 5. This negative and this negative, when they multiply, they're going to give us a positive. So that would be negative 4 plus 5. So if I want, I can start with this number which is positive, which is 5, positive 5, and then I'll write the one which is negative, which is negative 4. So 5 minus 4 is a 1, so down we're going to have 1. Negative 4 plus 5 is 1. Negative 4 plus 5 is the same as 5 minus 4, which is a 1. And we know that negative 2 divided by 1 is negative 2. So this is negative 2. That is the gradient for this question. Let's question 5. The Venn diagram below shows sets A, B, and C. Now the question is, use set notation to describe the shaded region. Use set notation to describe the shaded region. Now, when we want to describe this region we can see here which is shaded, how can we go about it? You can see that we are looking for elements which are in the set C, but they shouldn't be in B, they shouldn't be in what? They shouldn't be in A. How can we describe that? So one thing that should come in your mind is, you can see we've not shaded A and B. So this is A union B. We have not shaded. What is A union B? The row of this set you can see which you've not shaded, that is A union B. Okay, so we are talking of elements which are outside A union B. So we put a complement there. Well, they are outside A union B, but they are in the set what? They are in the set C. So I'm going to say A union B complement intersection C. They are outside A union B, but they are in the set C. So we've described the shaded region, which is just this one. It is A union B complement intersection C, meaning we are talking of elements which are outside A and B, but they are in the set C. Okay, question 6 is saying the vector PQ is negative 3 and 2. Given that the point P is 1, 4, find the coordinates of the point Q. We need to know a very simple way of working out vectors. Whenever you are talking about PQ, you should first, so this is a vector PQ, we mostly use a line on top to show that it's a vector. You should first get the second thing that is given, that is Q. You subtract the first thing that is given, that is P. So if we were given a B, we would have said first write the second thing given, that is B, and then subtract the first thing given, that is A. So that is how you show it. Now we've been already given PQ. PQ is what? They've given us negative 3, 2. Okay, negative 3, 2, that is PQ. And this is going to be equal to, what is Q? The question is saying find the coordinates of the point Q. So we don't know Q. I'll just write Q. And then minus P. Now what is P? P is 1, 4. I can write this point as a vector. I'll just put the 1 on top and then the 4 down. So then we've written it as a vector. So this is 1 and then 4 down. So what we are going to do is we are going to get this, we are going to take it to the other side. Now see, it is negative here, so if it goes the other side, it's going to be positive. So we have got negative 3 here and 2. So this is going to become plus 1 and 4 down. So this is going to be equal to Q, which has remained. So what we are going to do is, when you have got A, B like this, and then plus C, D, when you are adding, you just get those which are on top, you add them alone, and then get those which are down, you also add them alone. So in here we're going to have, what is on top in the first one is negative 3 plus what is on top, the second one is 1, and then in the first one, what is down is a 2 plus what is down in the second one is a 4, and this is going to be equal to Q. Now what is negative 3 plus 1? Negative 3 plus 1 is negative 2. So negative 3 plus 1, I can also write this as, I'll start with the one which is positive, which is a positive 1, and then write the one which is negative, which is negative 3. So 1 minus 3. Now, because we're subtracting a big thing from a small thing, it will always be negative. So this will be negative 2. And then if we add what is down, 2 plus 4, this is going to give us a 6. So we are saying we have got a negative 2 and 6, which is q. So we've written q as a vector. Now the question is saying find the coordinate. So if you want it to write as a coordinate, then q is going to be equal to what is on top is the x value, negative 2, comma, what is down is the y value. We just write like that. This is the answer that you want as a coordinate, not as a vector. So this is a vector, this is a coordinate, and we want a coordinate. So the answer is negative 2, comma 6. So we'll get to question 7 is saying given that r is 2, negative 1, 1, 3, and s is given as those. So we want to find s to the power t. So when you just see s to the power t, it just means the transpose of s. Now when you're talking about the transpose of a matrix, what was like this changes and becomes like this, and then what was like this changes and becomes like this. So we swap what was a row becomes a column. So that is the meaning of a transpose of a matrix. So write as s to the power t is equal to, we are going to have the first one here is 1, the one which follows is 0, it will be down, the next one is negative 4, it will also be down. We are done. And then these ones here, we're going to write them second. The first one is negative 2, and then a 1, and then a 1. Just put them in a matrix like that. So this is the transpose of the matrix S. That is how you write the transpose. Now the next one, we want to find RS, meaning we want to get the matrix R, which is 2, negative 1, 1, and 3. We multiply it by the matrix S. That's the meaning of RS. Matrix S is 1, 0, negative 4, then negative 2, 1, 1. So when you are multiplying, you're going to multiply the row and the column. So it will be 2, you're going to multiply it with this one. That is going to give you 2 times 1 is a 2. And then you come now to this one, negative 1, multiply with this one. So that will be negative 1. Of course, this is a negative. So negative 1 times negative 2, that is going to give you positive 2. So you're going to add those. When you are done with that one, again go to this one times 0, that is going to be a 0. Now write it along there, and then come again to this same negative 1, multiply with this one, that will give you a negative 1, so write it there. And then again come to this 2, multiply with the 1 at the end, 2 times negative 4, that will give you negative 8. And then the same negative 1 here, multiply with the one which is down, negative 1 times 1, which is negative 1. So when you are done with those, I'm going to rub this and then write it again so that it will be clean. We have got 2, 1, negative 1, 3. And then we have got 1, 0, negative 4, negative 2, 1, 1. Now we'll get down. Remember, I was just using the ones which are on top. So when we get down again, this one we can see here is going to be multiplying what is on top. This one we can see is going to be multiplying what is down. So this one multiplied by 1, that is going to be 1. And then this one is going to multiply with this one. So 3 times negative 2, that will be negative 6. When we are done, the same one which is here is now going to multiply this second one. 1 times 0, that is a 0. And then this second one, which is a 3, now multiplies this one. 3 times 1, that is a 3. And then again, the same one, the 1, is going to multiply now this one, which is on top again. 1 times negative 4, that will be negative 4. And then the 3 is going to multiply the one which is down here. 3 times 1, that is going to be 3. And this is going to give us 2 plus 2 is a 4. 0 minus 1 is a negative 1. Negative 8 minus 1, that's negative 9. and then 1 minus 6, that's negative 5, 0 plus 3, that is a 3, negative 4 plus a 3, that's a negative 1. So that is going to be for this one. That's how you multiply matrices. Always make sure that when you're multiplying a row, multiply with a column.